Hello guys, welcome on Tesla Adventures. In this video, we'll be discussing the level 2 problems for preparation of JEE Advanced and Olympiad. And in this video, I'll be using some easier problems initially and then we'll be pacing up to the tougher one. And in this video, you can easily analyze your preparation by pausing the video at every question and solving that question by yourself, and then after, if you want to check the answer, you can check the solution and video. Okay, so do this thing with each question. So let us start with this first question. You can see that this column 1 shows some graph of one-dimensional motion of a particle, and x0 is the initial position, xt1 is the position at time t1, and v0 is the initial velocity. These are the symbols which have these meanings. In column 2, there are some physical quantities, and displacement and distance are being asked for this time period, and the average values are asked for also this time period. A, B and V0 are positive constants. So in the first case, in the first option A, you can see that this is a position time graph and this is a graph. So you can see that initially the displacement or the position was positive, and then the displacement became negative. So displacement is continuously decreasing from A to B, and obviously this particle is having a one-dimensional motion. So if displacement is continuously decreasing, then you can see that particle is moving in the backward direction, negative x-axis, and therefore this is a in this case you can see that at any point velocity is not zero, which means that particle is not coming to rest at any point and it is not changing its direction. So distance and displacement would be same. So option P is one of the correct answer of this A. Now you can see that the instantaneous velocity and instantaneous speed are the same things. So you can see that instantaneous velocity magnitude is equal to the instantaneous speed magnitude. Obviously, if this particle is not changing its direction and it is moving on the linear line, and it is performing a one-dimensional motion, then its instantaneous velocity and the magnitude of instantaneous velocity and the instantaneous speed will be same. So Q is another correct answer of this one. And now in the R option, you can see that average speed and average velocity are average speed is either greater than or equal to average velocity. So you can see obviously that we are taking one possibility that average speed is equal to average velocity. So we can say this, that average speed will be equal to average velocity, because the distance and displacement magnitude are equal. So R is also the correct answer. And option S, that instantaneous acceleration is equal to the average acceleration. So instantaneous acceleration and average acceleration, you can see that instantaneous acceleration and average acceleration would be equal if acceleration is constant. So if this graph, this is the graph which can be there is no knowledge is given in this graph that is this graph a parabola or not. So if it was a parabola, then we can say that instantaneous acceleration and average acceleration would be equal, because if this is a parabola, then this parabola is opening towards negative x-axis, and in negative x-axis the x would be proportional to t square. So in this case, in fact, minus x would be proportional to t square. So in this case, now if we talk about this relationship, then it is a parabolic relationship, and if we double differentiate this relationship to find out the acceleration, then we can say that acceleration is constant, and then the instantaneous acceleration and average acceleration would be equal. But it is not mentioned in this question, in this figure, that it is a parabola. So we cannot assume that it is a parabola. So we are not placing this S option here in the correct matching. So and the D option, which says that the displacement is a minus b and distance is a plus b. So we have already discussed that in this motion, in this graph A, the body has never turned around, so distance and displacement are same. So obviously option T is also not the correct choice. Now option B is that VT graph is a straight line which is going up, and this area is A, this area is B, and initially the displacement was 0. So as you can see that velocity time graph is going up and it is starting from a negative velocity, and this graph ends on a positive velocity, which means that at moment of time t1 the velocity becomes 0, which means that body turned around, and therefore we cannot say that distance and displacement are same things. Now obviously the instantaneous velocity magnitude is always equal to the instantaneous speed, so Q is the correct answer, and the average speed is greater than the average velocity or equal to. So obviously in this case distance would be greater than the displacement, and hence the average speed would be greater than the average velocity. So the correct matching is R also. And in the S option it is mentioned that the instantaneous acceleration is equal to the average acceleration, which can only be possible if the acceleration is constant. So you can see that this is a straight line graph which is going in the upward direction, and the slope of this graph is constant. So if the slope of this graph is constant, then acceleration is constant. So average acceleration and instantaneous acceleration are same thing. So S is also correct choice, and the displacement is a minus b and distance is a plus b. So obviously displacement is a minus b, because the area of VT graph above x-axis represents positive change in displacement, and area of VT graph below x-axis represents the negative change in displacement. So the net change in displacement would be a minus b, and net distance travel would be a plus b. So the correct option is T also. Okay. Now for option C, you can see that in option C the acceleration time graph is given, and initially position was 0, and at t1 position was A, and at t2 position was B, and initial velocity is 0, in fact v0. So in this motion also you can see that the acceleration is always positive and initial velocity was plus v0, and therefore the body would be accelerating throughout the motion, throughout the time interval of 0 to t2, and therefore it never turned back, and hence distance and displacement are the same thing. So P is one of the correct answers. And obviously instantaneous velocity and instantaneous speed are same in magnitude, and the average speed is greater than the average velocity or equal to. So we would select the option R, due to the fact that there is a equal to mark also present in this option. And the fourth is that the instantaneous acceleration is equal to the average acceleration. So in this case you can see that the acceleration is variable. So for variable acceleration, we cannot say that the instantaneous acceleration is equal to the average acceleration. So therefore option S is not the correct matching of this option C. And option T, that the displacement is A minus B and distance is A plus B. So it is also wrong, because distance and displacement are equal in this case. So the only correct matchings are P, Q and R for option C. Now for option D, this is a parabola. It is mentioned in the question that this is a parabola which is opening towards x-axis. So you can see that velocity will never be negative, obviously. So P is the correct answer, because distance would be equal to displacement, And obviously q is also correct because instantaneous velocity and instantaneous speed would be equal in magnitude. And now option R, that average speed would be either equal to or greater than the average velocity magnitude. This is also correct because in this case average speed would be equal to average velocity because distance and displacement are equal. So R is also the correct option. And S, that the instantaneous acceleration is equal to the average acceleration. Let us discuss this point, that v square is equal to 4x. Now 2v dv is equal to 4 dx, and v dv by dx is equal to 2. So this is the acceleration and it is constant. So constant acceleration, for constant acceleration we can say that the instantaneous value of that acceleration and its average value are equal. So S is also the correct answer for this option. And T, that the distance and displacement are different, it is wrong for this option. So the only correct answer for option D is PQRS. Okay. Now we move on the next question. Now in this question, the first column has some velocity time graph and second column has their suitable displacement time graph. We have to match the options. So option A is VT graph is a straight line which is going up, and we know that when VT graph is a straight line which is going up, then a displacement time graph is a parabola which is opening in the upward direction. Okay, so you can see that at t is equal to 0, velocity was 0, and then velocity starts to increase. So displacement time graph would be a parabola in the opening in the upward direction. Now at t is equal to 0, velocity is 0, and therefore the base of displacement time graph, which is parabola, should occur at t is equal to 0, because at base of parabola the slope is 0 and slope of displacement time graph is velocity. So this is not a correct choice because its base is not at origin. Also its base is not at origin. This is not correct choice because it is opening in the downward direction, as well as this is not a correct choice. And this graph, you can see that at t is equal to 0, its base is at this position. Okay, so we can say that at t is equal to 0, parabola has its base. So the correct matching for this option A is only t. Now option B is a straight line which is going in the upward direction. Initial velocity was negative, then at some time velocity became 0. So you can see that this should also be a parabola whose mouth is opening in the upward direction, and at some time after start its parabola base should occur because the velocity is 0 after some time from the start. So the base of the parabola should occur at some time after the start, which is also in this problem. Now you can see that this graph is going up more up than this position. So we can say that the net area above the x-axis is greater than the area below the x-axis. So the net change in displacement is positive for this graph. So we can say that this displacement time graph would go in the forward direction, upward direction. So one of the correct option is obviously P. And now let us check that Q option. You can see that in this case there is no information which is given that at t is equal to 0 particle is starting from origin or not. So there is no sufficient information is provided in this graph about the initial position of the particle. So we cannot predict that the initial displacement was 0, negative or positive. So Q can also be the case. R cannot be the answer because R is a parabola whose mouth is opening in the downward direction, and this is also not possible. And this graph is also not possible because at this point t is equal to 0, its base is occurring, which means that in this case the velocity is 0 at t is equal to 0, but at t is equal to 0 you can see that its velocity is not 0. So the only correct options are P and Q for the B option. Now for option C, C is a VT graph which is going in the downward direction. So if VT graph is going in the downward direction, then a displacement time graph would be a parabola opening in the downward direction. Now this parabola would have its base at some time t naught. Let's suppose this is t naught. So first of all, P and Q cannot be the correct options, and let us see that obviously T is also not correct, and S is also not correct because its base is not occurring in this first quadrant. So the correct option will be R for C. Now for D. In case of D, this is a VT graph which is starting from negative velocity and it is a straight line going down. So obviously this is the displacement time graph would be a parabola which is opening in the downward direction. So P and Q cannot be the options, correct matchings. Now let us examine R. So you can see that initial velocity was negative in this case, and in R option initial velocity was positive because slope initially was positive. So R cannot be the correct choice. In fact, in this case, S option, the initial velocity was negative, and you can see that velocity will never be zero at some defined time. So its base is also not occurring at any time in the motion. So S would be the correct choice, and T cannot be the correct choice because the mouth of this graph is opening in the upward direction. Now let's move on the next question. In this question, you can see that again there are some graph for a particle which is moving on positive x-axis, which are illustrated in column 1, and these quantities are v, x and t, represents velocity, displacement and time, and column 2 gives the correct interpretations of these graphs. So first option, or first A, is the Vx graph is a straight line, which means that V is directly proportional to x, which means that let's suppose V is equal to Cx. Now dV by dx is equal to C, and A acceleration is V dV by dx. So V dV by dx would be equal to C into Cx. So A would be equal to C square x, which means that the correct matching for this case, this option A, would be the particle has a non-uniform acceleration, which is q. So q, and acceleration is directly proportional to x, which is s. Okay, now for option B, you can see that v square is proportional to x. So you can see the equation of motion, which is the third equation of motion, v square is equal to u square plus 2as, as u is 0. Therefore we can write it as v square is equal to 2ax. So this is valid in this problem. Therefore acceleration is uniform and acceleration is not variable. So the only correct option for this one is this is P. Okay. Now for C option, you can also see that velocity time graph is a straight line. So if VT graph is a straight line, then you can easily predict that equation of motion is valid, and therefore acceleration is uniform. So P is the option. And in option D, you can see that V square is proportional to, in fact, V is proportional to T square. So V is equal to some C T square, and dV by dt is the acceleration, A, is equal to 2ct. So acceleration is proportional to time and it is variable. So we can say that the correct answer is option Q, because it is non-uniform and it is proportional to time. which is R. Now we move on the next question. Now in this question you can see that there is a VT graph of a model rocket which is launched, and propellant burns for a few seconds and rocket accelerates in the upward direction. After burnout, the rocket moves in the upward direction for a while and then begins to fall. A parachute opens shortly after rocket starts to fall down, and parachute slows down the rocket to keep it from breaking. Now, when it lands, the figure shows the velocity time graph of this model rocket, and we have to answer the questions. So, you can see that the velocity time graph, velocity is plotted on y-axis, and velocity is measured in feet per seconds. So, we know that 1 meter 1 meter is equal to 3.37 feet. Okay, and the value of g is 32 feet per second square. Okay, if we exactly find out the value of g, which is 9.8 multiplied by 3.37, then it would be 32 point, in fact exactly 32. Okay, so this is the value of acceleration due to gravity. Now you can see that this is a graph. This is rocket going up and then it is falling freely, then this parachute opens. So the first question, that how fast was the rocket climbing when the engine stopped? So at, you can see at this instant of time, you can see that uh, this marking is having 5 blocks, 1 2 3 4 5, and the difference of each block is 10. So the rocket velocity at this point, I am pointing out, at this point rocket velocity was 190. So the correct answer is 190 for this one. Now for how many seconds did engine burn? So you can see that for 2 seconds the fuel burned. So the correct answer is 2 for this one. And when did rocket reached the highest point, and what was the velocity at that point? So at the highest point velocity is 0, and you can see that there are 5 blocks, 1 2 3 4 5, between 2 seconds span. So each block is 2 by 5 second. So 2 by 5 is 0.4. So you can see that this is 6.4. So 6.4 seconds is the time when rocket attained the maximum height, and at the maximum height the velocity of rocket is 0 obviously. Now so the answer of this is I think let us also again check. No, sorry. This is 8 seconds. This is not the x-axis. I mistakenly considered it x-axis. The x-axis is this one. So at 8 seconds, the rocket reached the maximum height, and the time and the velocity at that instant v was 0. Now, when did parachute opened up, and how fast the rocket was falling then? So you can see that the parachute opened at this time. So this is 10.8 seconds, and 10.8 seconds parachute opened up, and at this time the velocity of rocket, you can see that velocity of rocket was this one. This is minus 90. So if we are talking about the magnitude, then we can say that the velocity of rocket was 90, and v was 90, and the time at which parachute opened was 10.8 seconds. This is 10.8 seconds. Now how long does this rocket fall before parachute opened? So again it is being asked that after opening the parachute, how much time it would take this rocket has taken to reach the ground. Okay, so you can see that, I guess, how long this rocket fall before parachute open. So we have to find out the time of free fall of this rocket. Okay, so rocket was at maximum height at this point. This is the H max point, and after this point rocket fall freely. So this time span is 8. This is 10.8 and this is 8, so this is 2.8 seconds. So the correct answer of this one is 2.8 seconds. Okay, so this is 2.8 seconds. Now, when was rocket acceleration was greatest? So the acceleration of rocket is obviously the slope of VT graph, and the slope of this graph is highest at this position, you can see, because the graph is almost vertical. So at 2 seconds acceleration was greatest. So the correct answer of F is 2 seconds. Okay, now when the acceleration was when was acceleration constant, and what was the value of that acceleration? So you can see the acceleration was constant during the time in which rocket fall under the gravity. So free fall doesn't means that the object is only falling. In fact, any object which is projected in the upward direction under the effect of only gravity is also in the state of free fall. So after engine turned off, the rocket was in the state of free fall from this time to this time. So in this time, you can obviously say that rocket was falling under the effect of gravity, and therefore the acceleration due to gravity is the acceleration which is the constant acceleration, which is minus 32 feet per second square. So the correct answer of this is also minus 32 feet per second square. Okay, now we move on the next question. In this question, you can see that this is a displacement time graph of a particle which is moving rectilinearly in one direction. So we have to find out the average velocity of this particle during the time of motion. So you can see that during the complete motion, its final displacement was 2 and initially it was 0. So V average would be 2 minus 0 by the time taken. Time taken is 20. So V average is 1 by 10, which is 0.1, and it means that 0.1 meter per second, and V average you can write it as 10 centimeters per second. Okay, now the maximum velocity. You can see that in this case the particle is accelerating because this is a parabolic graph, and you can also see that the slope of this graph is increasing. Then the slope becomes constant, this graph becomes a straight line, and then slope starts to decrease. So velocity is increasing first, and then it attains a certain maximum value, and then it starts to decrease. So we can say that between these 2 points velocity is maximum, and the maximum velocity will be y upon x. Okay, this is x. So y would be V max would be equal to y upon x, and y would be equal to 1, 2, 3, 4, 5 blocks. So 5 blocks has a length of 1 meter, so it is 1 divided by these 2 blocks. So 5 blocks has a length of 10 seconds on x axis, so 2 blocks would have 2 seconds, in fact 4 seconds, so it would be 1 upon 4, which is 0.25 meters per second. So it is 25 centimeters per second. Now the instant of time when the instantaneous velocity is equal to the average velocity for t0 seconds. So let us suppose that at some time t naught, the instantaneous velocity is equal to the average velocity till that time. So obviously we know that if instantaneous velocity is equal to the average velocity, then the displacement of that particle, okay, displacement of that particle is exactly equal to the in fact, now the part C says that the time moment t naught at which the instantaneous velocity is equal to the mean velocity averaged over the first t naught seconds. It means that we have to find out that time at which the instantaneous velocity is equal to the average velocity. So we know that if we draw a tangent of this graph on this graph like that, you can see that at this point the velocity, instantaneous velocity, is obviously the slope of this graph. So this is v instantaneous, and the average velocity is also the displacement at this point upon time taken. So if you would find out the displacement, let's suppose the displacement at this point is s. So obviously s is this one, and the time taken till this point is t naught. So t naught is this one. So v average would be equal to s upon t naught. So it means that at this point v average is also in this direction, because this tan theta is equal to s upon t naught. So in this triangle, this tan theta is the slope of this line, and v instantaneous is obviously along this tangent. So at this point we can say that the instantaneous velocity and average velocity are equal, and this is the time which is 16 seconds. This is 16 seconds. So the correct answer for this one is 16 seconds. Now we move on the next question. In this question, you can see that this is a position time graph of a particle which is traveling along x-axis, and we have to state the true or false among these statements. We know that first statement says that the particle starts from rest at t is equal to 0. So you can see that the tangent drawn to this graph is this, and its slope is not 0. Slope is not equal to 0 at this t is equal to 0. Therefore velocity is not 0. So A option is false, obviously. Now particle is retarding in the interval from 0 to t1 and accelerating in the interval from t1 to t2. You can see that the slope of this graph is decreasing continuously, and it decreased to 0 at time t1 from some non-zero value. So speed is decreasing, so particle is retarding. Then again the slope starts to increase from t1 to t2, and hence we can say that particle is accelerating in t1 to t2. So B option is true, and C option is the option that the direction of acceleration has changed once during the interval 0 to t3. So you can see that the slope is decreasing continuously and velocity became 0 here. So the particle was initially moving in the backward direction and acceleration was in the forward direction. So eventually particle came to rest, and then it starts to move in the forward direction, and displacement starts to increase in positive direction. So acceleration is in forward direction. Now again you can see that this slope starts to decrease and decrease to 0. So again body starts to retard and moving in forward direction, which means that acceleration has changed the direction once. So this option C is also true. Now we move on the next question. In this question you can see that there is a xt graph, and xt graph is of a particle which is moving along positive x-axis. Now we have to write down, we have to answer the correct points at which the question is satisfied. So the first option is that the negative velocity but have acceleration in positive x direction. Which point has the negative velocity but acceleration in positive x direction? So you can see that at point A there is no acceleration because xt graph is a straight line. In region BC the velocity is 0 in fact. At point D velocity is positive, and at point E you can see that velocity is negative, because if we draw a tangent then its slope is negative, and acceleration is positive because you can see that this curve is opening in the upward direction, therefore acceleration is positive. We can say it directly, although we can see that this slope is having some finite magnitude at this point and it is decreasing, and at this point the slope becomes 0, which means that at point E velocity is in negative direction, but eventually after E it would become 0, which means that velocity is in negative direction at E, but it is decreasing in magnitude. So we can say that acceleration is in positive direction. So the correct answer of first is E, and anywhere else it is not happening that velocity is negative and acceleration is positive. Now the second question says that at which point the velocity is positive but acceleration is in negative x direction. So you can see, let us rub this one. So you can see that velocity is positive, so velocity is positive at this point, and this parabola is opening in the downward direction, therefore acceleration is negative. And at G point also velocity is positive, and at this point G this parabola is opening in the downward direction, therefore acceleration is negative. Or we can also say that at point D the slope is positive, which means the velocity is positive, and as we will move on the curve then at this point the slope would be 0, which means that while moving from D to this point the velocity is positive and it is decreasing, which means that velocity is positive and acceleration is in negative direction. And also at point G velocity is positive and above G it is 0. So G and D satisfy this point 2, and if we check this point 2 at point F, then we can say that velocity is positive at F but its slope is increasing, so it means that acceleration is also positive at F. So the correct answers for second question is point D and G. Now question C, that this particle has received a sharp impulse, which means impulsive force which is acting for a very less period of time, very low period of time. So you can see that at point B and C, in fact at point B the velocity was non-zero, and suddenly at B velocity becomes 0, which means that in negligible time velocity has reduced to 0. So the change in momentum upon time taken is almost infinite because time is negligible. So there is a large force acting on this particle at point B, as well as the same thing goes with C. So we can say that at point B and C a sharp impulse is acting on the particle. Okay, now we move on the next question. In this question you can see that there is a particle which is moving on a straight line under the effect of these four graphs. This x, v and t represents the position, velocity and the time of the particle, and we have to choose the correct graph for the three questions. So in first question it is written that in which of the following graph the magnitude of acceleration is decreasing with time. You can see that if xt graph is a parabola which is opening in the upward direction, then it is 100% sure that Vt graph would be a straight line going up and acceleration would be a positive constant. So this is not the case for first option. In this you can see that this is a Vt graph and slope of this graph is continuously decreasing. So acceleration, magnitude of acceleration is decreasing with time for graph B. So one option is B, and you can see that the slope of this graph is negative although, but it is also continuously decreasing. You can see that slope is decreasing, magnitude of slope is decreasing. So C is also the correct option, and option D is incorrect because as we are going in the forward direction, the magnitude of slope is increasing for this graph. Now, in which of the graph the magnitude of acceleration is increasing? So this is obviously option D. And if this body is definitely going away from the starting point with time, then which of the graph represents this condition? See, this body has started from some point, and in all of these four graphs velocity is positive. You can see that velocity is, although in this graph it is decreasing, in this graph also it is decreasing, but it is positive, which means that object is moving in the forward direction. And in this velocity is also positive, and it is a straight line graph, Vt graph for this option. So velocity is positive and in all of these options, and therefore object is definitely moving away from the starting point. So the correct options for the third question is A, B, C, D. Now we move on the next question. In this question, you can see that there are two particles A and B which starts from same point and move along a straight line. The velocity time graph for both of them has been shown in this figure. We have to find out the maximum separation between the particles in the interval of 0 to 5 seconds. You can imagine their motion that A is having a lesser acceleration than B, but the time at which A started was t is equal to 0, and the time at which B started was t is equal to 2 seconds, which means that B started after A. So initially B would be behind A, and then B would increase its speed with respect to A because the acceleration of B is greater than A. So initially at 2 seconds, what would happen that this is, let's suppose this is x is equal to 0, and B is starting at this point with some 0 velocity, and A has moved by some distance x in this time, and the time at this moment would be t is equal to 2 seconds. So this is the time at which B has started, and A was already moving at this time, and A was ahead of B. Now we can easily analyze the situation that B would eventually overtake A, and at some time when their relative speed would be 0, then we can say that the separation between A and B would be maximum, because till that time when A was speeding up, so if VA is greater than VB, then their relative separation x relative is increasing till VA is equal to VB, x will increase, and if VB is greater than VA, then x relative will start to decrease, which means that the time when their velocity will become equal, the separation will be maximum, and therefore you can see that at 4 seconds their velocity is 10 meters per second. It is the velocity of both A and B. Therefore till 4 seconds, at 4 seconds VA is equal to VB, and it is equal to 10, and therefore till 4 seconds their relative separation, x relative, will be maximum. And obviously their relative separation would be x a minus xb, and the area of x a graph is xa, which is half base into height. Base is 4, height is 10. So half 4 into 10, which is 20, and xb till this time is half 2 into 10, which is 10. So x relative maximum will be 20 minus 10, which is 10. So the maximum separation between them would be 10. So the correct answer is x max is equal to 10. Now we move on the next question. In this question, you can see that it is a acceleration displacement graph of a particle which is starting from rest from x is equal to 0. So we need to find out the speed of the particle at x is equal to 10. We have already discussed in previous section that the area of ax graph, which is a dx, represents v dv, and the complete area a represents v square by 2. So the velocity at 10 seconds can be calculated by calculating the total area. You can see that the total area A would be half sum of parallel sides, which is 10 plus 8, into height, which is 8. So it is equal to 320. Okay, you can see that it is in fact not 320. It is 18 into 4. This is 18 and this is 4. So this would be equal to 72. Okay. So this is the total area, and 72 is equal to v square by 2. So v will be equal to 12. So the correct answer is 12. Now we move on the next question. In this question, you can see that there is a particle whose initial velocity is 10, and its acceleration versus time graph is shown in the figure. This graph is a straight line which is moving in the downward direction, and its slope is constant throughout. So it is very simple that the VT graph would be a parabola. So velocity time graph would be a parabola whose mouth would be opening in the downward direction, and its initial velocity would be 10, and therefore this parabola would be like that, because its slope is 0 at the point where acceleration is 0, because the slope of velocity time graph represents acceleration, and acceleration is 0 at t is equal to 4 seconds. So at 4 seconds we can say that the slope of this graph would be 0, and this would be a parabola whose mouth would be opening in the downward direction. You can see that the area of AT graph above x-axis and below x-axis is equal. So delta V would be 0, and therefore the body will return to its initial velocity, and which is 10. So this parabola will return to this point again, and till 4 seconds its velocity would be maximum, and the maximum velocity would be half base, it is 4, into height is 10. So this is 20. So this is the change in velocity till 4 seconds, and the initial velocity was 10. Therefore we can say that this peak would be 30. So the correct velocity time graph of this problem is this one. Now we move on the next question. In this question you can see that this is a velocity time graph of two particles A and B which are moving rectilinearly on x-axis. So these two graphs are plotted for a time interval of 0 to 2 seconds. First of all, in question A, we have to find out that at t is equal to 1 second, which particle received a severe blow. You can see that at 1 second the velocity of A was -4 and suddenly it became +4. So A suddenly changed its direction without changing the speed, which means that A has received a sudden blow. And if we check out the option B, then you can see that in option B velocity is moreover same, but acceleration has changed suddenly, which means that the force acting on the particle has changed its direction. So this is not a impulse, and obviously then we can say that A particle has received a severe impulse at 1 second. Now we have to plot the displacement time graph of these two particles. So we can see for particle A, you can see that this Vt graph is a straight line going in the downward direction. Therefore, displacement time graph would be a parabola whose mouth would be opening in the downward direction. And you can see that this velocity is 0 at t is equal to 0. Therefore, the base of this parabola would be at t is equal to 0. So Vt graph would be a parabola opening in the downward direction. Base would be at this point. Now we have to find out this coordinate. So you can find out the area of this graph. So this area is A1. So A1 will be equal to half base into height. Base is 4, height is 1. So it is equal to 2. So this displacement is -2 because this area is below x-axis, which means that the change in displacement is negative. Now you can see that in region 1 to 2, this graph is a straight line again going in the downward direction. Therefore, a displacement time graph will again be a parabola opening in the downward direction, but its base would be at 2. And you can see that the area A2 would be equal, A2 is also equal to 2, but A1 represents positive change in velocity and A2 represents negative change in velocity, which means that the particle will return, in fact, positive change in displacement and negative change in displacement, which means that the total change in displacement is 0, and which means that particle will return to its initial displacement, which was 0. So we have three information about the parabola: that the mouth of parabola is opening in the downward direction, it would return to its initial displacement 0, and its base would be at 2 seconds. So this parabola would be like that. This is 2 seconds. Okay, and now if we trace the graph of particle B, so we can see that the particle B, the velocity time graph of this particle B is a straight line going in the downward direction. Therefore, again, it would be a parabola like that same, which was initially like that, and this would be -2, and this time here is 1 second, and there it would be 1 second. And in this graph, you can see that this would be a Vt graph which is going in the upward direction. Therefore, displacement time graph would be a parabola whose mouth would be opening towards positive x-axis, towards upward direction, and its area is still in the downward below the x-axis. So we can say that the total delta x1 change in displacement here is -2, and delta x2 is also -2, which means that particle will go till -4 because these two area are below x-axis. So again we have two informations about this parabola, that its mouth would be opening in the upward direction, but it is going in the downward direction till -4, and its base would be at a point where the velocity is 0. So velocity is 0 at 2 seconds, therefore the base of this parabola would be at 2 seconds. So the correct graph would be like that. So this would be -4, and this time is equal to 2 seconds. So this is the correct displacement time graph for A, and this is the correct displacement time graph for B. Now we move on the next question. In this question, you can see that this graph represents the position of a particle on y-axis and the inverse of its velocity on x-axis. This particle is moving on a straight line and we have to find out the time taken by the particle to move from x is equal to 3 to 15. You can see that this area of this graph bounded with the y-axis, this area is dx and this is 1 upon v. So this area dA would be 1 upon v into dx, and we know that this is dt because dx by dt is equal to the velocity. This is dx by dt, it is equal to v. So we can say that the complete area of this graph bounded with y-axis, this area A bounded with y-axis would represent the time. So this area would be half sum of parallel sides into height. So A would be equal to half, parallel sides are 2 and 8. So it is 1 by 2 into 2 plus 8 into height. Height is this one, which is 12. So A would be equal to 5 into 12, which is 60. So it would take 60 seconds to reach from x is equal to 3 to 15. Thank you. Now we move on the next question. In this question, you can see that this is a velocity displacement graph of a particle which is moving on x-axis. So we have to find out that whether the acceleration of the particle is constant, decreasing or increasing. You can see that dv by dx is the slope of this graph and it is constant because it is a straight line. So let us suppose that slope is k and v is variable because v is varying. So acceleration is v dv by dx. So acceleration is v into k. So we know that v is variable. So acceleration is also variable and it is increasing because v is increasing. So let us write down that v is increasing. Now we move on the next question. In this question, you can see that a particle is moving along x-axis and its velocity position graph is shown as a curve. This APB is the normal to this curve and this normal passes through this curve at point P. We have to find out the instantaneous acceleration at this point P. You can see that this is a straight line going in the downward direction. So let us assume that AB line has a equation y is equal to minus mx plus c. You can see that it is passing through a point 4, 0. So let us substitute this coordinates. So y is 0 and x is 4 and c is c. So c is equal to 4m. So the line equation y would be minus mx plus 4m. Okay. Now the equation of this line PC is x is equal to 3. So these two lines are intersecting at this point. So let us find out the coordinates of y coordinate of this point. So let us substitute this x value in this equation. So y is equal to minus m into 3 plus 4m. So y is equal to m. Okay. So this is y and this is m. Okay. Y is equal to m. Now this angle theta, tan theta is equal to y upon 1 and this is equal to 1 x coordinate. This is y and this is 1. So y upon 1 and y is equal to m. So tan theta is equal to m. Now you can see that if you draw a tangent at this point like that, so you can see that this angle is theta and this angle is 90 minus theta. So tan the slope of this line dv by dx at point P is tan 90 minus theta, and tan 90 minus theta is cot theta, where tan theta is m. So cot theta is 1 by m. Now we know that acceleration is v dv by dx. So acceleration at this point would be v, which is the y coordinate, m, and dv by dx is the slope, which is 1 by m. So acceleration is 1 meter per second square. So the correct answer is 1. Now we move on the next question. In this question, you can see that there are two particles. This is 1 and this is 2, and they are moving along x-axis. The position time graph of particle 1 is shown, and the velocity time graph for the particle 2 is shown. We have to find out the time when these two particles will collide, and we have to find out the position or the x coordinate where they will collide. Initially, it is given that initially particle 1 was at x naught, and x naught is equal to ut naught, and particle 2 was at origin initially. So first of all, let us analyze the situation. You can see that, let us suppose that this is x-axis, okay, and this is origin. And we can see that the first particle 1 is at x naught, which is equal to ut naught, and the second particle 2 is at this position. Okay, now you can also see that the velocity of this particle 1, initial velocity u1, is the slope of this displacement time graph, and its slope is x naught by t naught with a negative sign, which means that the initial velocity is in the reverse direction, negative x-axis. So it is equal to x naught by t naught. I have not used a negative sign because I have already assumed that u1 is in the backward direction. The initial velocity of this particle 2 is u in this direction. You can see that u2 is equal to u, and now finally you can see that the value of u1 is also u, because if you substitute the value of x naught by t naught, then it is u. The acceleration of particle 1 is 0, a1 is 0, because this is a displacement time graph and it is a straight line. The acceleration of this particle 2 is a2 is equal to the slope of this graph. So its slope is negative. You can see that it is u by t naught. So acceleration is in backward direction. So let us draw the acceleration in backward direction. So the acceleration is in backward direction a2, and it is equal to u by t naught. Again, I am not using this negative sign due to the fact that I have already assumed that acceleration is in the reverse direction. The separation between these two is x naught initially. Okay, now you can see that u relative is equal to u2 minus u1. I am assuming 1 as observer. So u2 minus u1 would be 2u. A relative is a2 minus a1, and it is minus u by t naught. And the relative distance which this particle 2 has to move to collide with particle 1 is x naught. So x relative is x naught. X relative is x naught. Now we can use the equation of motion. S is equal to ut plus half at square. So S is x naught, u is 2u, time is t, minus half, acceleration is equal to u by t naught into t square. Okay, so this is the equation, and you can use this quadratic equation. T square into u is minus 4 u t naught and plus t naught x naught into 2. Okay, so this is the quadratic equation. So the time of collision would be plus 4u plus minus under root of b square, which is 16u square. In fact, this would be 4ut. Okay, and into t naught. Okay, so this is 4u into t naught plus minus under root 16u square t naught square, and plus, in fact, minus 4 into 2, 8 u t naught x naught. Now we know that x naught is equal to u t naught. So x naught is equal to u t naught and divided by 2u. So let us eliminate u. So first of all, let us write down this t naught is equal to x naught by u naught, u. So you can see that t will be equal to 2u, u t naught is x naught, so this is x naught, and plus minus under root of, this is 16 x naught square, and this is 8 x naught square divided by 2u. Okay, so t will be equal to x naught by 2u. We will be taking this negative sign due to the fact that the first collision would occur in the lesser time. So the time of first collision would be the lower time. So there is a negative sign here, and this is x naught minus 2 root 2 x naught divided by, and this would be 4 also, divided by 2u. So you can see that this time t will be equal to 2 x naught is common, 2 minus root 2 divided by 2u. Cancelling this, so t will be equal to t naught into 2 minus root 2. So this would be the time at which they will collide, and we have to find out the position also where they will collide. So we can see that the velocity of this one is constant. So u1 is constant, u1 is equal to x naught by t naught, and it is u. So in this time it would travel a distance of y, let's suppose. So y, in fact, x dash. So x dash would be u into t naught into 2 minus root 2. Okay, so 2 minus root 2. So x dash will be equal to, this is x naught 2 minus root 2. And we have to find out the x coordinate of that point. So let us suppose that this is the point of collision and this will be x dash. So this x coordinate will be equal to x naught minus x dash. So x will be equal to x naught minus 2x naught plus root 2 x naught. Okay, so x will be equal to x naught is common, root 2 minus 1. So this will be the x coordinate of that point where they will collide. Now we move on the next question. In this question, you can see that a particle is moving on a xy plane and its acceleration time graph is given. This is the acceleration time graph in x direction, and this is the AT graph of y direction. Initially its velocity was y naught in y direction, and at t is equal to 0 the particle was at origin. Okay, now the value of a naught is given as v naught by t naught. We have to find out the time, we have to find out the angle with that velocity vector will make with x-axis at time t is equal to 4 t naught. So this is a simple problem. We know that ux is 0, it is given in the problem, and uy is v naught. And we know that the area of AT graph is equal to the change in velocity. So at t is equal to, or we can say that when time is between 0 to 4 t naught, the area of AX t graph will be delta Vx, and that area would be the area of these two rectangles. So it is a naught t naught, a naught t naught. So it is 2 a naught t naught, and a naught t naught is equal to v naught. So it is 2 v naught. And we know that initial velocity along x-axis was 0. Therefore, the change is equal to the final velocity along x-axis. So it is 2 v naught. Now delta Vy is also the area of this graph till 4 t naught, and you can see that these are 4 triangles. So area would be half into 4 into a naught t naught, which is again 2 v naught. But we know that initial velocity was v naught in y direction, so final velocity will be the sum of initial velocity and change in velocity. So it would be 3 v naught. Now this particle is moving with velocity v at 4 t naught time, and the component of this velocity along x-axis is 2 v naught, and along y-axis it is 3 v naught. So the angle this velocity will make with x-axis will be 3 by 2. So the correct answer will be 3 by 2. Now we move on the next question. In this question you can see that there are two particles which are starting simultaneously from origin, and they are moving along positive x-axis. Their initial velocity was 0, and the acceleration displacement graph of these two particles is shown in the figure. In the first part it is asked that if particle 1 and 2 takes t1 and t2 time to reach the displacement x0, then we have to find t2 by t1. You can see that for particle 1 acceleration is constant, and it is equal to 2a naught in this time. Okay, so this is constant, and by this constant acceleration it would travel x naught distance. So it would be half a, which is 2a naught, into t1 square. So t1 will be equal to under root of x naught by a naught. Now for particle 2. For particle 2, we know that it is also traveling with a constant acceleration of a naught. So to travel this distance x naught, it would take half a naught into t2 square. So t2 would be equal to root 2 x naught by a naught. Okay, so t2 by t1 will be equal to root 2. So this is the answer of part 1. Now for part 2, second part is that the time which particle will cover 2x naught distance in least time, and which particle will cross the 2x naught distance with greater speed. So you can again see that the time at which they will cross this point x naught is this one, and let us again find out the time in which they will cross 2x naught, additional time at which they will cross 2x naught. So let us suppose that additional time is t naught. So this is t naught 1 and this is t naught 2. Okay, so again we can say that at this position for particle 1, the initial velocity when it was at this position x naught is v is equal to v square in fact is v is equal to under root 2 into 2a naught into distance is x naught. So v will be 2 under root a naught x naught. And for particle 2, this initial velocity, I can write it as u1 u2. So this is u1 and this is u2. For particle 2, this initial velocity, or particle 2, the initial velocity u2 would be under root of 2 into a naught into x naught. Okay. Now you can see that with this velocity, they have to travel a distance of x naught. So let us find out the time. So the time they would take to travel this distance x naught. Now you can see that the acceleration of 1 in this region is equal to a naught, and the acceleration of 2 in this region is equal to 2a naught. Okay, so you can see that the particle 2 is traveling with a greater acceleration but less initial velocity in this region, and particle 1 is traveling with a lesser acceleration but greater initial velocity in this region. Now let us find out the velocity with which they will cross this position 2x naught. So v1 square will be equal to u1 square, which is 4a naught x naught. I will write it down here. So v1 square is equal to u1 square, which is 4a naught x naught, and plus 2a naught into x naught. So v1 will be under root of 6a naught x naught, and v2 square will be equal to u2 square, which is 2a naught x naught, plus this is 4 because 2 into 2, a naught into x naught. So v2 will be also equal to under root of 6 a naught x naught. Now you can see that these are the values of velocities of both these particles. Now let us analyze their VT graph. So the answer of this part B, that which particle will cross this point with greater speed, is the fact that they will cross this point with the same speed. Now we have to find out the time. So let us analyze their velocity time graph. So for particle 1, the velocity was equal to, this one is 2x naught into a naught. Let us suppose that this is root 2u and this is u. Okay, so let us suppose that this is u and this is root 2u. So for particle 1, the initial velocity was root 2u, and the VT graph is a straight line, and the time taken by it to reach the 2x naught is t1. So this time is t1, and this velocity is we have already written that it is 6 under root 6 a naught x naught. So we can say that it would be root 3u. Okay, so this velocity will be root 3u. This is root 3u. So this is the VT graph of the first particle, and VT graph of the second particle would be like that it is starting from u, and this is v2, and it is going in the upward direction, and its velocity is root 3u, and the time it takes is t2. So you can easily see that if we find out the area under this area bounded between this graph and x-axis, time axis, so this area would represent the displacement traveled, which is x naught. So x naught will be equal to half base into half sum of parallel sides into height. So it is root 3u plus root 2u into height is t1. So x naught is equal to half u t1 into root 3 plus root 2. And from this graph you can see that x naught is the same displacement traveled but at different time. So this would be half root 3 u plus u into time taken is t2. So you can see that t1 is equal to x naught 2x naught upon u into root 3 plus root 2, and t2 will be equal to 2x naught upon u into root 3 plus 1. Okay, so this is t2. Now easily you can see that if we find out t1 by t2, then t1 by t2 would be equal to root 3 plus 1 upon root 3 plus root 2. Obviously root 3 plus root 2 is greater than root 3 plus 1. Therefore this ratio is less than 1. Therefore we can say that t2 is greater than t1. So the least time is taken by particle 1. So particle 1 will take the least time. In this question, you can see that there are two particles A and B which starts from rest from origin, and their acceleration time graph is shown. The only difference between A and B is the fact that B has started after a delay of 1.1 seconds. So we have to find out their displacements, and in fact we have to find out the difference of their displacements or the distance between these two particles finally. So let us analyze their velocity time graph. First of all, they are starting from origin with zero velocity. Initially they were at rest and their acceleration is positive and continuously decreasing. So I can say that their velocity would be positive and would be increasing, but the rate of increment of velocity would be decreasing because acceleration is decreasing. And finally they will attain a maximum velocity of 60 and they will move with that velocity forever. The only difference between these two is the time lag of 1.1 seconds. So let us analyze these VT graphs. You can see that I am plotting this graph for A. You can see that the velocity, the slope of velocity time graph is acceleration, and acceleration of both of them is decreasing. So I can say that the slope of VT graph would be decreasing and V would be increasing, and finally the slope of VT graph would become 0. So just a assumption that this graph would look like that. I'm not saying that this is a parabola, but it would look like that, and this is the time t is equal to 10 seconds at which it will attain this velocity 60. So let us see that this area A1 is this is A1. Now let us draw the VT graph of B. So the VT graph of B would also look like that, but after a delay of 1.1 seconds. So it will start at 1.1 seconds and this would go like that. This is 60 and this would go like that, and this time at which it will attain this velocity 60 would be 11.1 seconds. So now this area is also A2 and A1 will be equal to A2. Now you can see that if I further draw this time, this which is 1.1 seconds, this is 11.1 seconds, then you can see that the area beyond this time, this area A2, in fact let us suppose that it is A3, and this area A3 beyond this time would be same. In fact let us write it down as A4. So A3 would be equal to A4. Therefore the difference of the displacements of A and B would be this area only. So this area would be the difference of displacement. So x relative would be this area A5, and A5 would be equal to 1.1 into 60. So it is equal to 66 meters. So their relative separation would be 66 meters. Thank you. In this question, you can see that a car manufacturer usually tells a optimum speed V0 at which car should be driven so that to get the maximum mileage. In order to find out that optimum speed of a car of new model, an engineer of that car experimented a lot and finally plotted a graph between the extreme time, which is the time for which a full tank of petrol lasts, and versus the speed, constant speed at which car was running. So you can easily see that on y-axis there is the time it would take a full tank of fuel to get empty, and on x-axis it is the velocity, constant velocity with which the car was running. So let us suppose that this is the time for which car was running and this is the constant velocity with which car was running. So the distance traveled by the car will be this time into velocity. Okay, so this is to maximize the mileage of the car, this x should be maximum, and therefore the product of t into v should be maximum. So if we write down the equation of this line, then let us write down that y is equal to minus mx plus c, and y is time, and this is minus mx is v plus c. You can see that at v is equal to 10, time is equal to 20. So 20 is equal to minus m into 10 plus c. So m, 10m minus c, or we can say that c minus 10m is equal to 20. Now you can see that at v is equal to 150, this time is equal to 4 by 3. So 4 by 3 is equal to minus m into 150 plus c. So c minus 150m is again equal to 4 by 3. So by using these two equations, we can see that 140m is equal to 20 minus 4 by 3, and 140m is equal to, this is 60 minus 4 by 3. So it is 56 by 3. So you can see that it is 8, and this is equal to 20, and m will be equal to 2, in fact m will be equal to 2 by 15. Okay, and this c will be equal to 20 plus 10m, and m is 2 by 15. So c will be equal to, this is 4 by 3, this is 2 by 3, and 2 into 2 is 4 by 3. 4 by 3 plus 20 is equal to 64 by 3. Okay, so m is 2 by 15 and c is 64 by 3. So t is equal to minus 2 by 15 into v plus 64 by 3. This is the time, and the product of t into v is equal to minus 2 by 15 into v square plus 64 by 3 into v. Now let us suppose that this product is x. So dx by dv should be 0 for this product to be maximum. So it is minus 4 by 15 into v plus 64 by 3. It should be 0. So v should be equal to 64 into 15 by 3 into 4. So it is 16, and this is 5. So this is 16 into 5, which is 80. So v is equal to 80, and it is the optimum speed. V optimum is 80, at which car should be driven so that mileage is maximum. And we have to find, if the fuel capacity of this car tank is 50 liters, then we have to find out that what maximum mileage can be obtained from this car. So it is very simple, that mileage is the maximum distance driven, which is x max upon the fuel in liters. Okay, so the value of x can be calculated by this equation. So x will be equal to 2 by 15 into 80 square. 80 square will be 6400 plus this is 64 by 3 into 80. And there would be a negative sign here. So this x max would be approximately 850. And mileage would be equal to 850 upon 50, which is the fuel capacity. So it is 17 kilometer per hour per liter. So this would be the mileage of, I'll write it down with different color. So this would be the mileage of that model car. Okay, now this was the last question of this video, and I hope you have gathered some knowledge in the toughest problems of graphs in level 2, and what you should attempt in each these kind of videos in which I'm illustrating the numerical problems, that you should pause the video at each question and you should attempt that question on yourself, and then if you get stuck somewhere in between the solution, then you can resume the video and you can see that what I have done. So I'll be taking the next topic in the next video. Thank you.